caching strategies. They help us to improve system performance. They dictate how and when the data is read or written from the cache. Some of the common strategies are cache aside, write around, write back, write through, etc. Let us go through them, and in the end, we can discuss which strategy is better for which scenarios. Cache aside strategy is the most widely used caching strategy. Think of it like bookmarks. If you want to find a Jira ticket, you'll first go to the Jira platform, then try to find that ticket. What if you bookmark it? So next time you want it, it is available. That is cache aside strategy. Some of its characteristics are read heavy. It means when the number of reads are significantly higher than the number of write, this strategy will help to improve system performance. Lazy loading means only the data that is requested will be loaded. No preloading of the data will be done. Some of the applications include blogs, product catalog, dashboard, user profiles. In write flow, the data will be first returned to the database because the database is the source of truth. And then it will be returned to the cache in a synchronous or asynchronous manner. In read flow, the application will first fetch from the cache, and then if it is found, it is a cache hit and the data is returned. If it is not found, that is a cache miss and the data will be fetched from the database and then later returned to the cache in a synchronous or asynchronous manner so that next time you want it, it is available. Advantages are fault tolerant because even if your cache goes down, the data will be served from the database. However, it will be slower. Memory efficient due to lazy loading, and since we are making two separate calls to database and cache, both of them can have different schema, more optimized schema. Disadvantages include initial slowness because the first request will go to the database and have additional latency. Stale data means whenever a new data comes and you save it into the database, after that any request that is going to the cache until the new data is reflected onto the cache, those will provide older data, that is stale data. And in thundering herd, it means, for example, if your cache data expires and a lot of request comes in that for that key, which is a hot key, all of the requests will go to the database and then choke your database. So in order to avoid it, you can use lock or mutexes, but again that is an additional complexity. So this is the most widely used high performance caching strategy. Write around caching is a high performance caching strategy. When the number of writes are significantly higher than the number of reads, this pattern helps to improve system performance. It has on-demand caching, which means the data is only loaded into the cache when it is requested. In the write flow, application will directly write to the database, which is the source of truth. This is where it is different from cache aside pattern, in which the data is saved to both cache as well as the database. However, the read flow is exactly same as cache aside pattern. Application will fetch the data from cache. If it is found, that is cache hit, it will return the data. If it is not found, that is cache miss, it will fetch the data from database and save it to the cache with certain TTL in a synchronous or asynchronous manner. Some of the applications include log aggregation system, time series data, etc. It supports high number of writes because the data is directly written into the database. And it also prevents cache pollution because only the requested data will be loaded into the cache. It is not suitable for read after write pattern. Consider user profile. When we update certain field, we want to read it immediately back. Over there, cache aside pattern works better. It has slow reads after the first write because the data is read from the database. And it will also provide some stale data when there is data already present for a cache key into the cache and new data is returned for that cache key into the database. Until the TTL expire, it will serve the stale data. So this is the high performance high write caching strategy. Write back strategy is a high performance caching strategy. When the number of writes are significantly higher than the number of reads, it helps to improve performance. The data is first returned to the cache and then to the database, so there can be some lag between them, and hence it's an eventual consistency and not a strong consistency. It is suitable for non-critical data like YouTube views, Twitter likes, etc. When there is new data, it will be written directly to the cache and then to the message queues in a synchronous manner. From message queue, it will be returned to the actual database in an asynchronous manner. We can use either message queue or brokers like SQS or Kafka. Let's say after writing the data to the cache, there are some failures while trying to write to the message queue or broker. How we can address them? One option is to use exponential backoff with retry. Worst case, we also call to the DB in the same API call. It will be slow, however, it will ensure that the data is returned to the actual DB. Then there is a transactional outbox pattern where we write the record to a local DB and there is a background worker running which will fetch from this local DB and then push to SQS or Kafka. We also need to ensure that in case while saving to this local DB there are failure, we either roll back the cache or you first try to save to this local DB, and if it is successful, only then try to save it into cache. Also, since it is much more better to have a single process, there is also an option of write ahead log. Since it has a separate recovery process, it is faster than outbox pattern, but it is lesser reliable. You also need to accept the risk that it is more suitable for non-critical applications. So if there are any failures, you basically just log the error and have alerting set up on top of it so that you can capture and retry those. What if your message queue fails itself while sending the data to the database? You try to capture those using dead letter queue. Read flow is very simple and similar to cache aside pattern where you capture the data from cache. If it is not present, you fetch from the DB and store it into the cache. Since the data is directly returned to the cache, it has a higher write performance and it supports high concurrency. We can also batch the data from the message queue or brokers so that it has reduced load while writing to the main DB. Disadvantages include risk of data loss, and since we have to handle so many failure scenarios, there is a complication in the implementations as well. It is best for high writes and non-critical data application. Write through is a strong consistency caching strategy. We make synchronous writes to both the cache as well as the database. It is suitable for read heavy workloads where accuracy is important. For example, your bank account balance. If you want to read your balance from the cache, it needs to be accurate. Other such applications are shopping carts, flight reservations, etc. You use it when we cannot read stale data even for few milliseconds. In the read flow, application will first fetch from the cache. If there is a cache hit, it will return the data. If it is a cache miss, it will fetch from the database and save it to the cache with some TTL in a synchronous or asynchronous manner. This is exactly similar to cache aside patterns read flow. In the write flow, app will write to the cache first and then to the database in a synchronous manner. While writing it to the cache first, if there is a failure, you return failure in the API. But if the data is returned to the cache and then while writing it to the database there is a failure, you need to handle it. The first way to do it using retries. But if you use exponential backoff with it, there will be higher latency. Let's say even after retries there is a failure, you need to roll back the data in cache, which can be done using invalidation. And the third way is database first, in which you first write the data to the database, and then while saving it into the cache there is a failure, you invalidate the cache and let the read handle the request next time. However, this is not write through caching in true sense. Some of the advantages are it has no stale data because your data is in sync with cache as well as the database, and it is suitable for read after write patterns. Disadvantages include slower writes because you are writing to both cache and DB, and so it will have higher latencies. It is not fault tolerant because of synchronous writes we are making to cache. If there is a cache failure, all the subsequent writes will be blocked. There is no benefit for write once data patterns like log aggregation system, and we need to handle complex failure scenarios in this caching pattern. So this is the high accuracy, strong consistency caching strategy. deciding the right caching strategy. Let us go through few scenarios and try to identify the right strategy. Consider product catalog with real-time pricing. Now that is a read-heavy workload. Product and pricing information may change occasionally, but you cannot display outdated information. Cache always need to have latest data. So the recommended strategy is cache aside strategy. You cannot use a write back strategy because it writes first to the cache, and since pricing or product catalog is a critical information, we do want it to be written directly to the source of truth, that is the database. Since this is a read after write pattern where you will immediately read after writing some information, write around caching does not make sense because it is more suitable for write once pattern. However, you can use write through caching, but that will be an overkill since it does maintain consistency between the cache and the database in the same write API. Also, the latency will be higher in that case. So cache aside strategy is better here. Let's go through another scenario, which is shopping cart. So multiple users can modify the same cart. Read must always reflect the latest cart. Write frequency is occasional, but correctness or consistency is quite critical. In this case, we can use write through caching. Again, write back strategy cannot be used as we cannot write critical information of cart directly to cache. It has read after write pattern, so you can skip write around caching. And since cache aside strategy can serve stale data, which we do not want as correctness is important, we cannot use that as well. So we'll go ahead with write through caching. In order history, there is high write throughput, rarely read, and if your cache is accessed, it improves subsequent performance. So for example, if you go to my orders, there is a higher chance in the next few minutes you are going to access it again. So in this, write around caching makes more sense. Other strategies can be avoided since this is a write once kind of scenario. And the last case we can go through is video view count. It means as soon as you view a video, you need to increment the count as well as show it to the user. So this is an extremely read heavy, write heavy workload. Accuracy is not critical, eventual consistency is acceptable. So if you show 98 and the actual views are 101, that's fine. But your DB should not be hammered with every view count. You can increase it in the cache and then batch update into the database. So write back strategy makes the most sense here. So this is how you can decide which strategy to use when.